right, so to begin the topic, I'm talking about architecting e-commerce. And so about an hour ago, I talked to actually this gentleman right here, and he informed me that my e-commerce demo site is down, which is wonderful. It's great to begin to talk about that e-commerce and having your demo site down. I promise you the actual code actually works. Heroku has a code limit, and I'm not paying for their database. Thank you for a free database that doesn't work anymore. So I'm David Henner. You can find me at GitHub here. You can find me at Twitter here. I don't tweet too much. This is my e-commerce project where you can find it at ror-e. As I said, I already failed fast because my demo doesn't work. I want to give the organizers of the event a good round of applause. They've done an awesome job here. Also, if you're expecting DHH, sorry. You might not like the fact that I'm not DHH. This is where I blog. This is also where you can find the demo site that's broken. And an interesting thing, I was doing a little Google search trying to find interesting photos to actually put in the slide. And what I came up with is I typed in architecting e-commerce because that's a slideshow. And then I went to images, and the first image I saw was this. Well, that's pretty awesome. Anyways, so what are the keys to success? What are the keys to success when you're building an e-commerce system? I think the first key to success is the talk that we had yesterday is communication, talking to your business guy. You got to find out what they actually want to build, because there's no one e-commerce solution that's actually going to be fitting every different business model. You might have a flash site that you're going to have a different inventory things. You might have downloads that I was just talking to a gentleman about. You could have a lot of different options, and depending on what you want to build, different options might be available. The first thing that Mr. Tom Cruise here is going to ask you, though, is, hey, listen, you're in Ruby. What are my options? The three projects in GitHub that I've actually looked at a little bit is Spree. They're the kind of the big dog in the house. There's my project, which is ror-ecommerce, and then there's Piggyback. And you'd use them all for a little bit different reasons. Piggyback's kind of like if you just want a shopping cart that does no shipments, no inventory tracking. You just want to just get an item and sell it real quick, easy. It's not something I'd necessarily use, but that's okay. Then there's Spree, that's big dog. They've decided to go in the architecture that's more engines based, and it's pretty good depending on what you want to use it for. I would say I would use it for they have other engines you can plug into it. If they have an engine that you can plug into it and it just works for your system and it gets you out the door and you're not going to try to do a lot of modifications to it later, then it's great. If you're going to try to do a lot of custom code later, I find it to be difficult to use, and a lot of people eventually kind of extract Spree out of its core and build their own system around it after a while. But this talk wouldn't be much about that if we weren't trying to do it ourselves. So it doesn't mean I recommend doing it yourself. It means that this talk is about doing it yourself. Anyways, so moving on. The one thing you really have to pay attention to when you're actually building e-commerce is start paying attention to all the moving parts day one. Don't go into, okay, I need to put products in here, so I'll create the product model, and then I'll create this, and I'll create that. You got to start, you can't just think about merchandising, you can't just think about inventory. You got to think about the whole stack, prepare yourself for the things that you're actually going to be changing. Because if you don't think about shipping when you're building your orders model, and then all of a sudden day one comes and you have to start building shipments, and if you model this wrong, it's just going to go wrong. Hello? So, yeah, got Tom Cruise back in here, so we got to talk to the business guy. And, well, I don't remember why. Oh, I just like Tom Cruise. Anyways, that's not true. So the reason why you need to talk to the business guy at this point is to ask and educate the business guy and say, hey, listen, what are your requirements? What's your time frame? Have you thought about the admin areas that you need? Do you need to actually have an admin area where you're actually going to have a customer call in and check them out? What are your expectations? You got to actually set their expectations too, whether you can finish a project in 3 months or 6 months. And then how much are you going to pay me? And there's a lot of education process going on with this first part of any project, really. I'm going to go back to what I basically just said earlier. You got to think of the whole stack day one. And a lot of people will say, don't over-engineer things. I'll say that slogan doesn't give you an excuse to ignore what you know is going to come up. There's a lot of things that you don't want to over-engineer day one, I agree. But if you ignore these things, you're going to model it wrong, and your life is going to be a pain in the ass. Oh, shit, I didn't say that. So common issues. Everything seems to be an afterthought, that when you're starting to build these things, you don't even think about shipping, returns, coupons, how are you going to do deals, how are you going to do marketing. I've seen simple sites that don't even do a password reset, and all of a sudden you're on the phone dealing with customer service. This is taking a developer now 4 hours at a time, and you could have just done this in less than an hour's worth of development. It's crazy. Another common issue I find is the cart knows way too much about the order, or the order might be the cart. And in all reality, the cart is a completely different object than the order, and different validations, different, essentially they're just completely different objects. And when you have different objects, then you need different classes, different databases. Don't try to mix these things up. Another common issue is the order doesn't take into shipping and returns. I've actually brought that up, and I'm going to go into that a little bit more later. A big issue I find is when you actually go and create an order, what happens is once you've made that purchase, that order should now be immutable. You should not be editing an order after a purchase, because that's a time stamp of history. You can now create new objects like shipping objects. You can create new objects like return objects and modify those. But that snapshot in history needs to stay stable, so you can actually go back and look at that and explain to your customer and say, hey, listen, this is what happened at this point in history, and figure out what really happened. So now we're going to go into the starting point of actually building an e-commerce system. And I think inventory is a really good starting point. I'm going to skip merchandising, meaning putting product into the site. So your solution depends on your business model, which means you got to go back to Tom Cruise. Tom Cruise, and you're going to have to tell Tom Cruise some things, and you're going to have to, I don't even know why I put Tom Cruise in there, I just like him. So you're going to have to explain, you're going to have to use some good practices. And some of the good practices of inventory, doing inventory is all inventory is transactional. Inventory is a separate object. It's not just a quantity field in your database for your product. Like it's not quantity 5 that are available. You're going to have more than that, and it should be a completely different object than your product anyways, because well, multiple reasons. Quantity is also determined in SQL. I'm going to go through this a lot later, and essentially what that basically means is don't do any Ruby math in your system. And well, I'll get to that later. Inventory is its own model. I've already talked about that. So there's two options that I'm going to go through. One is kind of like the standard, easy option, and one is more for like an Etsy, if you're familiar with Etsy, or a flash site. And essentially that is where it's critical that you don't oversell, and it's also very critical that essentially you have a fixed quantity of product, and you want to guarantee the checkout process. Like when you put something in your cart, it's just not going to disappear out of your cart. The first option is kind of like the standard inventory model that I've seen most places, where you just have a count on hand, count pending to customer, and sometimes count pending from supplier, and that's really depending. That's one place where you have to go back to your business guy and say, hey, listen, if you have some product coming from a supplier, are we actually going to allow to sell that, or are we actually, what is the business logic there? But anyways, the count available, this count on hand is actually just how much you have in your warehouse, and then the count available is just the math of this count on hand minus the count pending to customer. And as I said earlier, using SQL math, it's really dirt simple to actually just do something like this, where now if you have an object coming, or if you have 2 requests at the same time, and one guy is checking out and he says, hey, this product should go down to, in Ruby, if you were doing it, you'd say, hey, the new count is 9, and then if you had another object that said, that took the inventory object out, or grabbed it out of the database and said, oh, let's go from 9 to 10, or 10 to 9 again, you'll have conflicts, and now you'll have your database saying 9. If you do SQL math, you're not going to have 2. I'm saying that messed up, but anyways, use SQL math. Here's another method here where you're. So when you have, you need to increase your count on hand or decrease, essentially it's just add count on hand, and then this would be a negative number if you have to take something out of stock. This is a slide that I just add personally for this guy over here. You have several implementation points that are trigger points where you can actually update your inventory, and essentially that's at authorization of payment, at shipment, at return and restock, and if you have a purchase ordering system in your system there, and manual adjustments. Manual adjustments you're only going to use if something falls off the stock and breaks. All of a sudden you can't sell it anymore. If you follow this and you just use these trigger points, essentially you should have an accurate inventory in your system. As I've stated before, you should not be using Ruby to actually determine your stock because of the essentially 2 objects coming out of your database. You're doing the math at the same time. You're shoving it back into your database, and they're both saying that going from 10 to 9, when in all reality the actual quantity should be 8. The major advantage of this inventory system is easy to implement. There's no need to clean up actual records in your database. Its disadvantages, it's best to actually have a low safety stock buffer. It's possible to be in the checkout and somebody loses an item. So essentially what happens is if you have your inventory system like this, when somebody puts something into their cart and they're going through the checkout process, somebody else will actually purchase this item. And when they're actually going through the checkout process, they lose that out of their cart, and they're like, what the hell? I thought I had that in my cart. Another option would be the Etsy/flash sale site. And there's actually many ways to model this, but essentially your inventory record indicates of a quantity of 1 item. So if you're purchasing, if you have 5 inventory records, it's equivalent to 5 different product. The key here is basically you have a product ID, a status, and a locked at. And essentially this system is great for the flash sale sites, and the reason being is flash sale sites, you only can sell, let's say, 600 items. And let's go back to here. Let's say you only have to sell 600 items. But let's say what you want to do is essentially when you're grabbing these items out of stock is you see this little random. This is really what I want to show you is this random function or the clause. Essentially what that's doing is, let's say you're trying to get the next one out of stock. If you didn't have that random there, what would happen is, hey, I want the next item out of my inventory. But what would happen is there's a lot of people going after that inventory at the same time. And if you actually all try to grab that piece of inventory at the same time, you're going to have to rescue out of this a lot of times. You still should actually have a rescue in here. I actually didn't write all the code necessary for this this code here, but essentially what happens is you'll have collisions in between, and everybody's going to be trying to lock the same piece of inventory. But if you do something like this and you're not grabbing the very next one out of stock, you're grabbing random, the chances of collision goes down significantly. The advantage of this implementation is great for flash sites. You can ensure that you're not going to sell more items than you have. There's not going to be a bug in the system because you can only get every record in the database is actually indicated of a physical item you can sell. You can't sell more than that because you can't even actually go through that process. You can't have 10 items in my cart and somebody else have 10 items in my cart, and for some reason there's a mistake and all of a sudden there's a bug or something like that. It's just really, really robust from that standpoint. The disadvantages is, let's say somebody's put something in their cart and all of a sudden they're not on the site for another 15 minutes or whatnot, and you have to go ahead and you have to create some sweepers that'll actually free up that space so now you can sell it to someone else because this person actually put it in their cart but they didn't actually purchase it. So you have to actually have a lot of extra code. You have to have that rescue code that I was talking about before. And another disadvantage, which really isn't really that bad of disadvantages, but you're going to have a lot of inventory records in your database. And that may or may not be a bad thing for, I mean, in all reality, it's not even that bad. Anyways, now let's move on to the cart. We're going to have to go back to our business guy. He's dancing. The cart. So I don't know why I put this here either. I think I just like Tom. All right, going to the cart. One thing I really want to stress, and I've already said it before, is a cart and the order are two different objects. You got to start breaking up your objects. And I'm going to say it one more time. The cart and your order are two different objects. I've seen a lot of systems actually just have an order object be your cart object, and that seems great until you actually want to do things like, let's say you want to break up your, and you want to kill some the cart objects out of your database. That's fine because the cart is not sacred data. But if you start doing that with your orders, your orders are sacred data, and you wouldn't want a bug in that software where you start deleting real good orders. Your orders should just be sacred and never muck around with them. Some of the good characteristics of a good cart is it's stupid, it's simple, it's not deletable, and what I mean by that is your cart is your number one point in your system that you can use for marketing. So when somebody deletes something out of their cart, really what it should be is a status change. And if you just change the status to inactive, now you can use this information for marketing purposes, whether it be a recommendation engine, you can actually upsell that person later, and you can actually, another good thing about a cart is it can be archived. It's very simple. Cart items are modeled something like this. We have a user ID, cart ID. Cart ID is actually stored in your session. Product ID, although in my project I call it variant ID. You have a quantity and status. The status is essentially what I just discussed, where it can be inactive, but you can also, this is an awesome place to actually have a save for later. It's essentially the difference between an item in your cart and an item in your save for later, or your item in your wish list is just a status. So now it's very easy to switch a product, but have that Amazon flow where all of a sudden you have items in your cart and all of a sudden you're like, oh, you know what, save for later. and then it just goes down later, and then all of a sudden you want to move it back to your cart. It's just a status switch. So it's really easy to actually indicate that. This is as simple as it gets. One other note I've noticed with a lot of different carts that I've seen is a lot of carts out of the box don't look at the quantity you have in stock, and they allow people to put things into their cart that isn't in inventory. That's just bad practice. I just wanted to note that. Moving on, at this point you have items in your cart and you actually want to check out. Probably going to have an education discussion with your business guy again. I probably should have added Tom Cruise here. And at this point, you're going to have to inform your business guy about security. I think we all know about SSL. I think we all know we want to do good security, but I think most sites that I've been to, if you're logged into the system for 20 minutes, it doesn't require you to go. It allows you to stay in the system for days and days and days and days, and you're not checking out, and you can check out at any time if you're logged in. Essentially, if you're logged in for more than 20 minutes of inactivity, you should require a user to actually relog in and go right back to the point where they were in the checkout. You don't want somebody's girlfriend to mess up their cart or their shopping experience. And also, don't store credit cards. It sounds so obvious, but I've seen places, seen so many sites that actually store your credit cards in your database. First off, this is wrong. Second off, there's laws around this. Third off, if you're actually trying to do it, the legal way to do it is you have to have a completely separate server that just stores your credit cards. You're not allowed. You're forcing yourself to secure. You're not allowed to actually expose first name, last name, CVV, any information about the credit card because you're storing the credit card in your own servers. It's just bad practices, and plus the actual credit card processors are actually really good, so it's just not worth your time. So when you actually start the checkout process, this is when your cart object moves over to your order object. And the order object simply looks like this, and if you notice, it looks very similar to your cart. So your orders looks very similar to your cart. So with one slight difference is your order items do not have a quantity. There are major implications if you do this. If you do have a quantity in your order items, now it's almost impossible to get a lot of use cases out of shipping. It's almost impossible to get a lot of use cases out of returns because what if I put 5 Nikes in my shopping bag and now I have a quantity of 5, but I only can ship 3 of them. Now all of a sudden your shipments just get all messed up. So you have 5 items in your, I'll repeat that. Basically you have 5 items in your cart, 3 of them you can ship and 2 of them you can't. How do you actually model that as far as shipping goes? You can't because the shipment would be pointing to 2 different, your order items would be shipping to 2 different times, and I don't even know how you'd actually go through that. Anyways, going back to the checkout, it's as simple as moving everything into the cart that's in the correct status to your order item. So now, moving on, essentially your checkout starts out as just orders with order items. I think everybody's seen this where they're going through their checkout, you add an address, then you add your billing address. But note one thing here, addresses are immutable. A lot of people get this wrong, and they allow you to go to your admin area and let's say you edit your own address. That's wrong because what will happen is, say I have an order from 2 years ago and it was shipped to New York. And all of a sudden I go in this week and I say, hey, listen, I'm going to change the address. And the address is going to go from New York, now I moved to California. If that actually is a new record, or if that's just really truly editing that address, that old order will be pointing to the wrong place of where it really actually got shipped. So what you have to do is every time you edit, it'll look like an edit to the actual end user, but in all reality, what you're doing is creating a completely new record, and you're inactivating the old one. I don't know if I'm getting some blank stares, so essentially, I'll repeat that again. You got your old address is now just inactive. It's the order items, the old order points to the old record in the database, and your new order points to the new record in the database. Now you have enough information to actually determine a shipping method. This is sort of how it's modeled out. It's kind of a little bit too small to read. So essentially what you have is a product. You know what product, you know the shipping methods that are available to the product through this little schema here. You know what shipping zone you're in because you know the address. So the combination of what shipping methods are available to this address and what shipping methods are available to this product, and you can figure out where it can be shipped to each product. So now you have, also you could add coupon, whether you need that. There's also promo codes. There's all sorts of little things that you can add in addition depending on what your business guy wants. Another thing I want to indicate is this completed at. When the order is complete, you actually mark this completed at date or time. And that's very important because essentially this is a snapshot in history, and you need to know whether this coupon was actually valid at that time. You need to know what sales in your system, if you create a sales system in your site, were available for this order at that time. You need to know what deals were available for that order at that time. Anything that you're doing with that order now, you're not using time.now anymore. You're using this completed at field to determine what the price was and what the price should have been for this order. And at this point, actually, at this point, the only thing that can change really for the order is the status. It's immutable. At the checkout, you're going to have to go, when you accept payment, when they click that, what really happens most of the time is you're authorizing it, but that's not necessarily true anymore. Most people have to ask their business guy and say, hey, listen, can you guarantee shipment? If you can guarantee shipment of an order, the law actually says, at least in the United States, I imagine there's a million different laws throughout the world, but in the United States, you do not need, you can charge immediately if you can guarantee shipment immediately. So now, as I said before, order is immutable. You can't change it. It is a snapshot in history. Don't be changing this thing. If you can't capture payment at the time of the user thinks that they have actually been charged, you capture it when you ship the item. So shipment is a trigger point for a payment. Moving on to shipments now. A lot of times I see people model shipping sort of like this, where an order has a shipment. And that's just not true, as we discussed a little bit before. It's not orders that have shipments, it's order items that have shipments. And that's really critical because, as I said before, you could have multiple shipments within an order, and like you've all been, well, maybe you haven't been through the Amazon checkout. I don't know if that's popular in Ukraine. But you've been through that where all of a sudden 3 items are shipped with one type of shipping method and another one is a priority because you just want that one faster. You have to model out like this. You don't need necessarily the order to the shipment, but that's kind of like a nice to have for your SQL later. So at the time of shipment, it's pretty easy. You subtract pending to customer, subtract count on hand with the first inventory system that I discussed. On to returns. There's an RMA process. Returns are very similar to shipments. And essentially, the return item is very similarly modeled like the shipping item, with the exception of you adding a condition and a reason. It's modeled something like this. And hopefully at this point, when you actually deliver this to your business guy, he's sitting there like this, eating some money or a cigarette. Now there's some more that I actually want to talk about that I can't go too far into, is accounting. In the project that I built, I made accounting very much a first-class citizen in my site, and the main reason being is I built this for startups that want to become huge. It's not for your mom and pop shop, and it will work perfectly fine for your mom and pop shop, but it's very important for when you're having 10,000 orders a day to get your accounting correctly, and it's almost impossible if you're just looking at your bank account. You can't really figure out what your accounts receivable is, accounts payable, and whatnot. It's pretty difficult stuff, but it actually really does help you. I think I already brought up addresses that are immutable. Coupons, I didn't go into how modeling that. I'd like, if I had more time. Same thing with deals and sales. Marketing is probably one of the coolest part of e-commerce. There's obviously retargeting pixels and tracking users' progression, but all of a sudden you start combining that with recommendations engines, and you start using your cart. What I discussed before is all of a sudden you have items that were deleted out of their cart, and you have items on their save list, and all of a sudden they're going through that checkout process, and now with a recommendation engine, with that information at your side, you can actually upsell them through their checkout, and it's really cool stuff that all of a sudden now you can double your sales because you actually keep this information. Another thing I did not bring up is all credit card processors are not equal, and they are not. Investigate which ones are available to you. I love Stripe. They're doing great work over there. They make it dirt simple for security. They're making it dirt simple just to actually just use many different widgets that they're building. Also, one other thing, if you are going to build an accounting system, here, if you go to my Twitter account, which is Henner, you can actually see the slides. I should have actually brought that up when I started, but see the slides to this presentation. Essentially, if you're going to try to build a double entry accounting system, this site makes it dirt simple where you can actually just implement it. It's pretty awesome. Lastly, if you're going to be building recommendation engines, these are two gems within Ruby that I actually have investigated. They're pretty good. If you're going to start tracking your users, I think most people know about Google Analytics and Kissmetrics. There's a gem that just recently came out called Ahoy. It's getting a lot of activity. I really like it. It allows you to now actually have the power, a lot of the power of Google Analytics within your Ruby code. So now if you actually have that and you combine that with a recommendation engine and everything else we've discussed, you can actually really have a kick-ass upselling and ability to market to your customers. And that's it. Thank you.